Hi folks, Dr. Bowers here. I'm very sorry about what happened with quiz 4. It became evident that there was a lot of questions that were not covered in the videos. So what we've decided to do is I'm going to make a video for each of the 4 questions on the quiz, and then we're going to open the quiz up for infinite tries and infinite time. So you can, infinite up to the end of the semester. So I hope that these videos will help you, and then you can go back and do the exact problem that they give you, and then get full points on the quiz. That's better than just saying, well, we'll drop the quiz, because that implies we should drop the topics, which really we shouldn't do, because these are really important topics for calculus. So I hope that this video helps you. Okay, so the first one says this is a trig question here, and the question is, determine if the equation represents an identity. In other words, is the tan squared theta minus secant squared theta equal to 1? So the first thing I'm going to do is play around with this, and it looks to me, well, if I say the tangent squared theta minus secant squared theta. Well, what is that? Secant and tangent. Let's put everything into sine and cosine. So the tangent is sine squared theta over cosine squared theta, and the secant would be minus 1 over the cosine squared theta. Well, now we have a common denominator, so that's basically equal to sine squared theta minus 1 divided by cosine squared theta. So we recall from Pythagorean theorem, right, that the sine squared theta plus cosine squared theta is equal to 1. So if I subtract cosine from both sides and then I put the 1 on the other side, we would get sine squared theta minus 1 is equal to negative cosine squared theta. So I can replace sine squared minus 1 with negative cosine squared theta. So this becomes negative cosine squared theta divided by cosine squared theta, which is equal to negative 1, which is not equal to 1. So this is not a true identity. It does not hold. And but let's explore this more deeply, because what's really fascinating and beautiful about this is, what does this look like? Because we're saying that for any theta, right, the sine squared theta minus 1 is equal to negative cosine squared. Or in this case, the tangent squared theta minus the secant squared theta is equal to negative 1 no matter what. So I looked at that on Desmos, and it's really fascinating. What you see here is the tangent squared theta is this blue here, and the secant squared theta is the green one here. So the function, the red one, tan squared theta minus sine squared theta, that's going to be taking, for whatever point, like let's take this one here. You take this value of the tangent squared minus this one here, and you can see that they're always 1 apart, so the answer is negative 1. Let's look at it at 0, right? We have 0 minus 1. That gives you negative 1. So the idea is that for every point, for every theta along this x line, excuse me, here, for every theta along this x line, the sum becomes negative 1. So hopefully that helps you understand a little bit more visually what's going on and why these hold. All right, let's go on to number 2 here. Number 2 says, write the trig function in terms of x. It's a little hard to see, isn't it? And then evaluate x if it's 0.5534. So we want to figure out what is the tangent of theta if the sine of theta is equal to x. And these are really useful for calculus, so it's important to understand this. What we're given here is that the sine of theta is equal to x. That could be rewritten as x over 1. So now if I just draw an average triangle here, okay, I'll put my theta here. That means that the sine is x and sine is opposite over hypotenuse, so the 1 is there. Now we want to figure out what is the tangent of theta. Well, the tangent of theta is equal to the opposite side, which is x, divided by s here, right? Or side, x for side. So we just have to figure out what s is. So, we could just use the old Pythagorean theorem here, and we have x squared plus s squared is equal to 1 squared. So s squared is going to be equal to 1 minus x squared. And so then the square root of that is the side s. And then it says we want the tangent of that. So the tangent then of theta is going to be equal to x divided by this s here, which is the square root of 1 minus x squared. And it's nice because in the directions it says type do not rationalize the denominator. So that was the first part of the answer. The second part is you want to stick in this value here, 0.5534, into that. So if I put 0.534 into that, I just use Desmos once again. Here's my function. G of x is equal to x divided by the square root of 1 minus x squared. And so G of 0.5534 is 0.6644. And you can see this is what the function looks like, kind of an S shape here, backwards S, I guess. And so at about 0.55, it's right about there. So that is 0.6644. So again, using Desmos and going back between Desmos and the algebra might help you understand a little bit more about what's going on. It's always fun to ask, what if? Why does that work like that? So that was number 2. Hopefully that helped with number 2. All right, let's do number 3 here. Solve the equation over the interval 0 to 2 pi. So in this case, we're going to have 5 times the cosine of x minus 7 is equal to 0. Okay, so now we say, just solving this normally, 5 cosine x is equal to, add 7 to both sides, 7. That was a 7, right? Yeah. And then I'm going to divide both sides by 5, and we get cosine of x is equal to 7 over 5. Now I know that 7 over 5, that's 1 2/5, which is 1.4. And now, one way to do this is we can use again the inverse function. So the arc cosine of the cosine of x is equal to the angle whose cosine is 1.4. So these two are inverse functions, and so we just get x because when you compose the inverse functions. And now we have the angle whose cosine is 1.4. Well, what's something that's odd about this is, remember that the cosine, there is no angle where the cosine is greater than 1, right? The cosine function looks like this. And so the highest it ever goes is to 1. So it could never, there could never be a point up here at 1.4. So thus, this cannot be solved. X cannot be solved. And the answer is the solution is the empty set. All right, the fourth one. Okay, the solution, the equation sine of 4t equals the square root of 3 over 2. So in this case, what we need to do is first, we have the sine of 4t is equal to, what was it again? Radical 3 over 2. Radical 3 over 2. So similarly, again, we want to take the inverse of both sides. So I'm going to say the arc sine of the sine of 4t is equal to the arc sine of square root of 3 over 2. So it's the angle whose sine is radical 3 over 2. Again, we're composing a function at its inverse, so we're just left with 4t, and that's equal to, again, the... Okay, I'm back. My children needed something. Let's see, now where were we? Okay, so we're trying to evaluate, again, the arc sine of radical 3 over 2, or the angle whose sine is radical 3 over 2. So if I want to draw this, I want to say that the sine, which is the opposite side, is going to be radical 3 over 2. And then the sine here, this is going to be 1, because it's radical 3 over 2 over 1 for the hypotenuse. And then this is going to be a right triangle, so that's going to just be pi over 3, right? That's pi over 3. And this would be radical 3 over 4, half, I'm sorry, 1/2. That would be 1/2. This is the side 1/2. So that's pi over 3. Now, it's also could be, don't forget that radical 3 over 2, the angle whose sine, it could be over here also. So it could, because this is, the sine is still positive in the second quadrant. So it could be radical 3 over 2 here and negative 1/2 here. And so this angle would be 4 pi over 3 minus pi, because this is pi over 3, right? So I'm sorry, 3 pi over 3 minus pi over 3. So let's start with this one first. So we know now that let me go back to purple here, okay? So in the first part, we have 4t is equal to radical 3 over 2. So 2 is going to be, I'm sorry, 4t is equal to pi over 3, so t is going to be equal to pi over 12. Now, on the other side here, we have this angle here, which was 4 pi over 3, this is 3 pi, I should change that color again. I'm not nearly as good as Saul Collin is here on using different colors. So we're going to say that's 3 pi over 3 minus pi over 3 is equal to 2 pi over 3. Okay, so then we can say 4t is equal to 2 pi over 3. So t is going to be equal to 2 pi over 12 again, or t is equal to pi over 6. Pi over 12 and pi over 6. So normally we could finish by saying that, going back up here, you want to find t, right? So we have the angle as pi over 12 and pi over 6, but that's going to be repeating every time pi goes around, every time theta goes around. So if it was a regular sine function, if it would be the, say the sine of x, that has a period that's equal to 2 pi. So we would say that t is equal to, I'm sorry, if this was the sine of t, right? Then we would say t is equal to whatever the answer was plus 2n pi. However, the period when the function is, in this case, we have the sine of 4t. Remember from harmonic motion, right? The period is equal to 2 pi divided by b, so that'd be 2 pi divided by 4. So now the period is pi over 2. So instead of this being t plus 2 pi, why did I write pi twice? All right, 2n pi. That's what that was, not a pi, it was an n. Instead, this becomes t is equal to, was pi over 12 plus pi over 2 times n. So where n is any integer. Now we can do the same thing with the pi over 6. We would have, this is going to be the sine of 4t, so the period's the same, but now we're going to have t is equal to pi over 6 plus pi over 2 times n. So those are your two final answers. I hope these videos have helped. And please feel free now to take the quiz, and hopefully it will be a lot more clear now. And